Okay, I wanted to revisit the Power Distro now that we've cut all the panels and installed all the devices and circuit breakers. So this is the Power Distro that I had been cutting out on the router in my previous video. And here I've installed all of the circuit breakers and all of the wiring to the devices. And first off, I used the QO series circuit breakers because they're a good circuit breaker that will actually trip in overcurrent situations, unlike some other circuit breakers that I've seen and used. And also they are panel mount, which makes this type of application really handy. In addition to that, the lugs are reversible, so you can mount the device and then reverse the lug, hopefully before you mount it, so that applying the wires and other cabling to them is pretty straightforward. They're also DIN rail mountable, but that doesn't apply in this application. So on the back of the distro, we've got L21-30 three-phase twist lock input, a circuit here that I broke the tab on this outlet, so the top and these two power cons are on a circuit, and the bottom of it and these two and this one power con are on a circuit. Each of these 515s here is a dedicated circuit, and then I also have two 240 volt L620 twist locks for my larger amplifier application. That isn't actually strictly necessary because the amplifiers could use 30 amps, 120 volts instead of 240. But I had these plugs and receptacles already in stock, and so I decided to go with a 240 volt option. So for power distribution from the connector here, I just jumped my terminals on the circuit breakers input. These circuit breakers permit that due to the way the screw clamps. So I just come in and then I jump to the next one. And then the output, some of them I split. As you can see, this outlet shares the circuit again with this power con on the front panel. And everything is phased, and my phases are pretty well balanced. On these outlets here on the back, I ended up splitting them, like I said, so each one has a 20 amp feed, but they're on the same phase and they share a common neutral. So I upsized the neutral to 10 gauge here because these are not across multiple phases. So if, for instance, you had 15 amps on each one of these circuits, it would overcurrent this wire because they're on the same phase. Now, you can't possibly have more than 15 amps on each one of these, even though they're 20 amp circuit breakers, because the maximum potential of the entire system is 30 amps, because this is a L21-30 three-phase receptacle. So maximum potential you'll see is 30 amps, no matter how you utilize the circuits. As far as the ground and neutral, this unnecessarily lavish bar here I got from McMaster. It's rated at 100 amps and I think it's 300 volts. And I got hooked, non-insulated hooked ring tabs, or excuse me, non-ring, the ones with the fork, so you don't have to take the screw out. And they have hooks on them here, which I thought was a nice detail, although unnecessary for this application. And I did heat shrink on all of the connectors that I crimped that were non-insulated. Again, that's probably not necessary for this application, but it did make a nice finish. So I'll take this over to the rack and I'll show you how it goes in the rack here. So this is the rack that I've been constructing. I fabbed up a cart down there out of 1 1/4 inch square tube with some 5-inch casters. I really like the 5-inch casters versus the 4-inch casters. They're a lot easier to roll on rugs. So naturally, I'll put this cover together, but I'm not trying to make you watch me do that. Let me get a screw in here real quick. So it doesn't fall out the front if I push on it. Okay, so of course this is a little shock mount cell with this rack rail in it mounted inside the larger case. And I did that partially because my case standard is actually wider than a standard rack rail, and I want to have the same width of every case. And also it allows me to push the gear out the front of the case, as you can see here, so that the depth of the lid is utilized. Cases I've built before, I often have an empty lid on it, and you lose a lot of truck pack potential with that, especially when it's adding to the linear dimension of the truck pack. So, and of course we also have some drawers in here. I fabbed up the drawers just on the router, and I just shot them together with glue, and I put these brackets on the top so when you do the pulling, it doesn't separate at the glue joint here. And they're also on the back as well. These are 22-inch deep drawer glides, and it seems like it's going to make a kind of a nice size drawer. Nothing fancy on the drawers, really. So the power, as you can see here, I've got L620 from my K10s. These amplifiers from one rack space here will do 6,000 watts per channel, so 12,000 total. That's why they're taking the larger power. And for a monitor amp, I'm going to have these here. These are 4 channels, 500 watts per channel at 8 ohms. So that will be a very solid monitor amp. And then I've just got a DBX drive rack down here. Again, that'll power here. And I'll have my L21-30 3-phase input here, which is, of course, 3 hots, a neutral, and a ground center pin, and a 10-gauge cable. I like the SEOOW cable standard. The SOOW has a smell to it, and I don't like the smell. So again, this is a 3-phase twist lock here. And so we'll have the show where we either have 3-phase cam lock inputs, and we'll have that distro that breaks down into multiple L21-30 outputs, and we'll just roll the whole rack up, plug it in one time, and have the power. On the odd chance that that is not available to us and there's no other way to power the distro from this standard, of course I will unplug all of the devices out of the back of the power distro. And for the L620 240 volt standard, I have an adapter made, which is NEMA 515 input, your standard Edison plug that everybody has in their house. And then it's got an L620 output, and that will adapt the K10s to 120 volt input, and they are switch mode power supplies built in, so they'll take any voltage. It's 115 to 230 volts, so it'll take anything thereabouts. So the L21-30 standard is going to give a 208 volt input on a three-phase system there. So I will be able to adapt this system to plug into any customer supplied power strips or any sort of ridiculous power situations we might get into in the situation where we didn't have standard power distribution. So I hope that's a helpful video. I don't know if you came here for the aluminum cutting and then I drug you through power distribution, or if you might have come for information about building power distros, and maybe this is helpful. Oh yeah, one other thing. If you're having any PowerSoft K10s, these plugs come in a straight version, which makes the cable stick way out the back of the amp, and it has a really stiff cable that comes with it. But you can buy these AMP connectors. You can buy the back half shell and just add it on. You have to sleeve it over the cable, of course, but that gets you a 90-degree connector there, which is pretty helpful. So anyway, thanks a bunch. I'll talk to you later, or thanks.